Welcome to our presentation on the performance study on network traffic analysis. This is a joint project by Elizabethtown College and the University of Massachusetts Lowell and Intel Corporation. This is a joint project by Connor and I, and it's advised by Dr. Lee. And we'll just get started here. We'll hop right into the agenda. So we're going to cover why is this important, our motivation, process, and approach behind the project, along with the basic machine learning models, deep learning models, DAO learning models, and then we'll also go into OpenVINO accelerated models. Lastly, we'll go into evaluation and cover the results of the project thus far.
All right, so firstly, why is this important? So with more connected device means there's more potential cyber attacks. Required precautions need to be taken against these increasing attacks. This is because once an attack happens, it can be very costly. So the business exposure to attacks jumped from 64% to 71% from 2018 to 2019. Another reason this is important is because of difficulties of finding comprehensive data sets. Researchers have always used different data sets, which makes it hard to replicate from past experiments. And makes it so we are unable to compare statistics since the data keeps changing because we're comparing different data sets. Another reason this is important is because acceleration is the next step forward. So as data sets get larger and larger, the evaluation time grows immensely. This is why fast detection speed is necessary in order to achieve malware detection from a network traffic standpoint.
We'll move on to the motivation behind our project. So the use of machine learning and deep learning models to detect cyber attacks on the network. And we're also going to be covering the implementation of DAO and OpenVINO in machine learning and deep learning. This is used for accelerating the baseline models that we have, and also the use of 3 different data sets in order to provide a comprehensive study and to be able to compare statistics with other researchers.
Next, we have the system overview. As previously said, this is a joint project with University of Massachusetts and the Intel Corporation. But our main focus is on the implementation of the models. So you can see the box that is circled. We're focusing on logistic regression, the random forest, 1D CNN, 2D CNN, and RNN implementation. They're both deep learning and machine learning models.
And our process includes data pre-processing, model implementation, data collection, and comparing results. So we start off with the data pre-processing and preparing the data for our models. We pass it along to our models and collect statistics from them, such as the accuracy and the training and testing times. And then that allows us to compare results.
Next, we have our approach. So originally, we took traditional machine learning models to train and test our data. And once we got that working, we implemented Intel's DAO, which what that does, it accelerates the machine learning. So we converted the basic models using Intel's DAO, and then it increased the training and testing times of our models.
Additionally, for deep learning, we took traditional deep learning models to train and test initially and collected the stats from that. And then we applied OpenVINO acceleration to those deep learning models in order to collect more statistics there. And we compared those, and we'll see those results later on here in the slides.
So here are the machine learning models that we tested. We have Decision Forest. Some pros and cons are it is easy to use, fast implementation, and accurate. Next, we have logistic regression. Just like Decision Force, it is easy to implement and effective, but a downside, it is not the most powerful model. So once the data sets get large, the training and testing time is going to go up greatly. Next, we have Support Vector Machine. This is accurate for many different problems and is widely accepted as a machine learning algorithm. But the downside of this is that training time gets very, very high once the data sets get bigger. And a way to combat this is to lowering the numbers of samples that we're taking from the data sets. Lastly, we have the K nearest neighbor. This is easy to learn, but just like Support Vector Machine, it gets slow once the data sets get large.
Then we'll go over to the deep learning models. So on here we have both the 1D and 2D convolutional neural networks, or CNNs. So the 1D CNN and the 2D CNN were difficult to set up initially, but once they were, it was very fast for testing once it was up and running. The only difference between the 1D and 2D CNNs was that for the 2D, data must be converted into a multi-dimensional format, which was a little bit challenging to get set up, but again, once it was set up and running, it was very easy to test with. And the recurrent neural network, or RNN, is the next step forward for our project. So being as we're 5 out of 8 weeks into our project, this is definitely the next step where we want to head with the project to better understand which models would perform the best here and to implement as many as we can here.
Next, we have the DAL accelerated models. So as previously said, we had machine learning models, and then we implemented Intel's DAL. Intel's DAL is a library of optimized algorithms used for solving large data problems. And the way it does this is it simultaneously takes the data and computes the results at the same time in order to assure the highest performance output. So the right graph, you can see the testing accuracy is nearly the same. It's a little bit worse for logistic regression, but the takeaway is the computation times. KNN and logistic regression, the computation time is much less than its regular standard model. The logistic regression standard took over 75 seconds, while with the DAL logistic regression, it took only 25 seconds. So it's only it's much faster.
And for the OpenVINO accelerated models, we leveraged OpenVINO to convert our existing 1D and 2D CNN models into these accelerated model formats provided by OpenVINO. Converting the model takes time, of course, but it greatly makes up for this with the speed at which it's able to process all of the data afterwards in order to test. So if we take a look on the left-hand side, we can see the inference times. These are the testing times here for the 1D and 2D CNN models. We have the standard labeled in red and the OpenVINO in blue. You can see the OpenVINO offers us a great performance increase here. It drastically reduces the time it takes for testing the data. The 1D CNN cuts it down by over half the time, and the 2D CNN is about 1/3 of the time that the standard method would take. And on the right hand side, we can see the accuracy there is neck and neck for both models, with the 1D CNN slightly outperforming the 2D CNN.
So next, we're going to have evaluation. As previously said, one of the biggest problems with the data sets and malware research is that everyone used to use a different data set, which made it hard to replicate people's findings or to try to improve on them. So this is where the two data sets that we're using come in. The NetML and the CICIDS data set are the two data sets that were made with this in mind, so everyone can have the same baseline. So the NetML data set is made for malware detection, and it consists of 500,000 network flow samples. And within those flow samples, there are 20 different types of malware and benign classes. And in the SIDS data set, it is also for Also for malware detection, it's 550,000 network flow samples, so a little bit bigger. And within that, there are 7 different types of malware and benign classes. Benign classes being good classes, non-malware. And these data sets are created by 2 companies, the Stratosphere IPS and the Canadian Institute of Cybersecurity, or CIC for short. And these data sets are open for the public research, so everyone can use them and try to improve on malware detection. And throughout our project, we are using the same computer with the and these are the computer specs.
And in conclusion, more connected devices means more potential cyber attacks, with businesses being most at risk for this. The use of the datasets NetML and CSIDs allow for a comprehensive study and comparing results with other researchers in the field. Acceleration is the obvious next step forward here for us, with DAO and OpenVINO contributing greatly towards this. With DAO, we're able to greatly accelerate the training and testing times, and OpenVINO takes a short amount of time to process into the OpenVINO model format. But once that's done, the testing times are greatly improved. And this will move us on to our Q&A portion of the meeting.